Okay, so we have been in geometry and advanced geometry. Both classes have been working on segments and how to set up equations with different segments. Today, we're going to talk about how to measure the length of a segment or the distance between 2 points, and also how to find the location of a midpoint on a grid. So some of you did the activity to start this lesson at the end of class the other day. Scenario is you caught a fish, and you want to measure how long the fish is, but the yardstick you were going to use to measure the fish with was dipped in paint, so you cannot see the numbers 0 to, we'll say, 5 on the first 5 inches on the yardstick. So how do you measure the fish? Well, most of my friends, they went down here and just started at 5 and said, Miss Benton, I know that if I just move the fish over and start at 5, and I know that fish goes all the way to 10, that fish must be 10 inches long. So I guess this is a ruler, not a yardstick, but that's okay. So what you did there is you took these two numbers and you just subtracted them to say that your fish would be 5 inches long. So that, my friends, is the distance between 2 points, horizontally or vertically. This works for horizontal or vertical points. You just take the 2 points and subtract, and that's your distance in between them. Remember, these guys are called absolute value bars, and the reason they're there is because when we subtract, we can sometimes end up with a negative number. And of course, in geometry, we're talking about distance, we're talking about length, and that is never negative. So remember, an absolute value bar, it just makes whatever is in there turn positive so that we don't end up with a negative distance or a negative length. All right, so here we go. Example 1. Use the number line or graph to find each measure. So we have BE, and for the first two, we're going to use this picture down here. So we're going from B to E, and the question is, what is the distance from B to E? So some of you might just count, right? 1, 2, 3, 4, 5, 6, 7. And that gets you the answer is indeed 7. A faster technique would be to say if the endpoint here is 4, the endpoint here is -3, so 4 minus -3 is 7. Either way, it gets you there. I would like for you to practice this new technique of subtracting the endpoints. Why? Because if you have really big numbers, if you want to find the distance from 5,433 to 479,632, you're not going to want to count squares. We might be here a while. Okay, let's look at same picture down here at the bottom. This time we're going to find the length from A to F. Now, so we're going to use the shortcut. I have 5 and -5. Order doesn't matter since it's in the absolute value bars. If you want to say 5 minus a -5, or if you want to say -5 minus 5, either way, you'll get the distance between the two to be 10. Okay, these were both horizontal distance. Let's look at vertical distance. Okay, so for vertical distance for G to H, again, you can count squares, or you can look over here at your y-axis. Here's 0, 0 right there. So 1, 2, 3, 4. And this is 1, 2, 3, 4, 5. So right off the bat, I know -4 minus 5 would be -9. Absolute values makes it positive, so it would be a distance of 9. Okay. I'm going to go ahead, pause the video, and find the distance yourself. You try I to J. Okay, so hopefully you paused the video and you saw that the distance here, this endpoint was 1 on the y-axis, this endpoint 1, 2, 3, 4, -5. So 1 minus -5, the distance between those 2 points was 6. Okay, notice that all of these letters combined, none of them had a line symbol above them. That's because none of these technically were indicating a line segment. All of these were indicating just the distance between 2 points. Okay, so there's a difference between AF with a line segment over it and AF without a line segment over it. This guy is the distance between 2 points. This guy is indicating a line segment AF. Just a little picky difference there. Okay, for our next activity, I need to make sure you remember how to work the Pythagorean theorem. Okay, so Pythagorean theorem, you might remember from your pre-algebra class, is a squared plus b squared equals c squared. And let me remind you that when we say A, B, and C are the sides of a right triangle, this only works for right triangles. It doesn't work for just any old triangle. Triangles, that's a triangle symbol, apostrophe S. Okay, and A, B, and C are the sides of the triangles. Now A and B, it doesn't really matter which side of the triangle they are, but C must be the longest side. C must be what's called the hypotenuse. The side across from the box, the longest side of your diagram. So you might remember, let me just give you a little quick review here. If you have 3 and 4 and this is x, in pre-algebra you said a squared plus b squared equals c squared. So you said 3 squared plus 4 squared equals x squared. You put 3 and 4 in for a and b, and you put the hypotenuse x in for c. You know that squared means a number times itself, so 3 times itself is 9. Be careful not to call that 6. It's not 3 times 2, it's 3 times itself. And 4 times itself is 16. So 9 plus 16, you said, let's go over here a little bit, is 25. And then your last step, and you may not remember this step, but if x squared equals 25 and we went just x, not x squared, the opposite of squaring something is square root. So the square and the square root cancel each other out. Oh, it's not that, my bad. All right, and so the square root of a number means what number times itself is 25. And the number that times itself is 25 is the number 5. So 5 is our answer. Okay. All right, so that's your quick little review of the Pythagorean theorem. I'm going to stop right there and we'll pick up on the next video.